Let's have a look at another example of using the elimination method to solve a set of simultaneous equations. Now, the elimination method is probably, it's best used for solving a set of linear simultaneous equations. So equations that don't involve powers. So this is a linear equation. There's another linear equation there. So let's have a look at this question. Okay, there's probably some more steps involved, or most likely some more steps involved compared to the last example. Solve the following set of simultaneous equations. So we have 2x plus 3y equals 4 and 4y equals 3x plus 5. So the first thing we're going to do is write the equations in such a way that the variables, the like variables or the like terms are lined up one under the other. So let's start off with this equation there. Okay, so 2x plus 3y equals 4. And now let's write down the second equation, but again, I'm going to line this up so that it's lined up under the first equation. So 3x plus 5 sort of equals 4y. Okay, so if I move the 3x over, okay, what do we have? So we've got negative 3x plus 4y equals 5. Okay, so that's just moving the 3x sort of over to this side. It becomes a negative 3x. So let's write that down under the first equation. So negative 3x plus 4y is equal to 5. We now have a set of simultaneous equations to solve in the correct format for elimination method. So let's have a look and see if we can identify a variable to eliminate. So again, we try and find the variables that are identical, both the coefficient and the term, the variable itself, the pronumeral itself. So we have a 2x and a 3x. Well, they're not totally identical. So the x's are identical, but the coefficients are not. We also have the y variables are also not fully identical. In other words, they're not identical enough for the application of the elimination method. You can't just add or subtract these two equations and sort of magically eliminate one of the variables. It's not going to work that way. We have a 3 here and a 4 there. So whether you're adding or subtracting these two terms, you're not going to end up with 0. So the first step is we need to somehow make one of the terms identical. So what we could do is maybe let's eliminate maybe the x variable or the y variable. I think let's eliminate the x variable. Okay, so we're going to do that by taking the coefficient of the second equation and multiplying the first equation by that coefficient. So we're going to multiply this entire first equation by negative 3. And then we're going to multiply the entire second equation by the coefficient of the first variable, which is 2. So let's multiply that by 2. And let's see what we end up with. So this might take up a little bit more space than the last video, so just bear with me. So multiplying this first equation by negative 3, we've got 2x times negative 3 is equal to negative 6x. 3y times negative 3 is minus 9y. And then 4 times negative 3 is negative 12. Now, second equation, negative 3x multiplied by 2 is negative 6x. We have 4y multiplied by 2 is 8y, positive 8y. And then 5 times 2 is equal to 10. So can you see now that we've basically come up with two brand new equations? They're still valid, so we haven't broken any integrity here. The left-hand side still equals the right-hand side. Multiplying an entire equation by a constant doesn't change the nature of the equation unless the constant's 0, of course. So well, let's not worry about that one. Okay, now we can eliminate the variable x, so this first term. So let's do that. Now the next step is, do we add them or subtract them? And I guess a good rule of thumb is that if the terms are identical in every way, including the signs, so if they're both negative or they're both positive, you subtract them. If one of them is plus, one of them is minus, or one's positive, one's negative, doesn't matter which order, you then add them together to eliminate them. So in this case, we're going to subtract. Okay, so sort of big minus sign there. Okay, and let's do that. So negative 6x minus 6x, well, that's 0. So that's disappeared, so I'm not going to put anything there. Negative 9y minus positive 8y. So negative 9 minus 8y, that's actually negative 17y. So think of it as minus 9 minus 8, negative 17, is equal to negative 12 minus 10, so that's negative 22. We now have a single equation with one type of pronumeral, so one letter there. So we have the y, so y is equal to negative 22 over negative 17. The negatives obviously eliminate there, so therefore y is equal to 22 over 17. So I just managed to squash it in there. And that's the solution for y. But that doesn't answer the question fully. We've just found one of the variables. And you can have answers that are, in fact, fractions or even irrational, surds even, depending on the nature of the equation, of course. So don't be afraid to tackle these kind of equations that might have fractions as answers. That doesn't mean that it's necessarily wrong. So I'm just going to add another column here. And I'm just going to sort of continue on. So finding the x variable. All right, finding the value of x. Okay. So we need to choose an equation, and we can choose any of the original equations. It's usually best to choose one of the original ones, of course. In fact, I might just choose the first one here. One of my little habits, of course, is to label these equations, and I like to do that. That way, at least I know what I'm referring to. So let's use equation number 1. Okay, so it's a good idea with simultaneous equations to label them, either A or B or 1 or 2. Okay, so from equation 1, okay, we're going to then substitute this answer here that we just found for y, then to hopefully find a value for the x variable there. So we've got 2x plus 3 outside of 22 over 17, okay, is equal to 4. So let's sort of rearrange this to make x the subject of the formula. So I highly recommend that the algebra, if you're not sort of quite au fait with that, to really hone your algebra skills. I think it's extremely useful in so many different ways. So 2x, I'm going to rearrange this equation, leave the 4 where it is, and I'm going to subtract 3 outside of 22 over 17. Now I want the x to be the subject, so I'm going to divide both sides by 2. So x is equal to 4 minus 3 outside of 22 over 17, all over 2. Notice that I haven't even evaluated anything, haven't used the calculator yet. So I'm just sort of moving things around. And I guess that's the beauty of algebra, that you don't have to rush to the calculator to sort of evaluate each line and it's sort of wasting time doing that. You can store right at the end. In fact, let's do that. In fact, modern day calculators, sort of current calculators, are quite adept, at sort of letting you enter in quite complicated expressions. So fraction, and we're just going to type this in and evaluate x. So 4 minus 3, and you can enter in a fraction inside a fraction. No harm in that. We can do that. So 4 minus 3 outside of 22 on 17. Remember, that's the value for y that we found. And then we're going to divide all that by 2. Okay, we get 1 on 17. Okay, so x is equal to 1 over 17. So these are our solutions. So therefore, x is equal to 1 on 17 and y is equal to 22 on 17. Now, if you can spare it, check to make sure that your answers are in fact correct. So this is what I suggest to do, and I guess it's not necessarily the best way, but if it sort of resonates with you that this this method works for me, then by all means use this method. So what I'm going to do is I'm going to use the memory function. So you see there's letters here in red. I'll go a little bit closer there. Hopefully, see if I can. Yep. Okay. See there's these letters here in red. We're going to store the values that we just found. The 22 on 17 and the 1 on 17 into these memory locations. So again, let's do that. So x is 1 on 17. So the way we do that is just type it in, 1 on 17, shift, just press it. Don't have to hold it down. RCL, and then the letter x. And you should have a thing on the screen looking like this. a fraction with a little arrow pointing to x. So that sort of, we've now substituted that value in to the pronumeral x, which is really cool. Let's substitute in now the value of y, sort of store that in the calculator in the correct pronumeral. So 22 over 17. Okay. Shift, store, and then y. Okay, and you should have this sort of coming up on your screen there as well. Okay. So if you use the alpha key now, so alpha x, for example, the value, if you press equals, you should get the value that you've just stored. So just to make sure that you've stored it correctly, alpha y, and you get 22 on 17. Right, now let's verify these two equations. Let's type them in. So if I type in 2x plus 3y, I should get 4 as an answer on the calculator. So let's do that. 2x, okay, plus 3y. It's pretty cool that you can do, I guess, kind of it's fairly simple algebra, but you know, on these calculators. And we get 4 as an answer. So I'm happy with equation 1. Those two answers we found, these two answers here, do work for equation 1. Let's try equation number 2. So that was negative 3x plus 4y. So negative 3x plus 4y. Now, bit of a drum roll. Do we get 5 as an answer? And we do. Excellent. So I am assured that these two values there are the solution to this set of simultaneous equations, and hopefully get the marks.